Okay, so things that you need to know at this point in the unit are the following. You need to know, how do you convert, please don't talk when I'm talking, how do you convert from degrees to radians or radians to degrees? So for instance, if I said to you 62 degrees, how would you convert that into radians? You need to know how to do that. Or if I said to you 5 pi over 3, you need to know, how do you convert this back to degrees? That's one thing you have to have memorized. Good? Another thing you need to have to memorize is positive and negative coterminal angles. If it's positive, which direction do I go first? Counterclockwise, going up. And if it's a negative terminal angle, we go clockwise, down. Thank you. Okay, the next thing came from arc length and area of a sector. So arc length, and to visualize that, that's like the crust on the pizza. Arc length is the formula S equals R times theta. R is the radius, and theta is the central angle. Now, what a lot of students in the rush of taking a quiz or test forget to do is theta always must be in terms of radians. So if it's in degrees, you have to transfer it into radians. And area of a sector, area equals 1/2 r squared times theta. And the same thing applies. Theta has to be in terms of radians. Now, a great question I heard students say is, when I multiply these or I multiply these, do I include the pi? And you do. You do include the pi when you're figuring out the arc length and when you're figuring out the area of a sector. Another student said, well, how do I know what to round to? You're going to look at the directions. It'll say round to the nearest whole number or round to the nearest tenth. Now, on Friday, we went over a lot of things, but they're based on trig functions. Based on trig functions. So here are the trig functions you should know. So sine, cosine, and tangent. Sine is opposite over hypotenuse. Cosine is adjacent over hypotenuse. And there's a couple ways that we write tangent. One is we say opposite over adjacent, or a lot of times when we were finding the exact value of a trig function, we say it is the sine over the cosine. We also learned what the reciprocals of these are. So cosecant, please say it for me. More than one person, cosecant. Okay, cosecant is going to be the reciprocal of sine. So yes, it is 1 over sine. The other way to think about it is it's just you're flipping. Whatever sine is, you're flipping it. If sine is 1 over 2, then cosecant is 2 over 1. So you can think of it as hypotenuse over opposite or 1 over the sine. The reciprocal of cosine is secant, not sec. Please say secant. Okay, and it's hypotenuse over adjacent, or think of it as 1 over the cosine. And your last one is cotangent, not cot. It's adjacent over hypotenuse, or cosine over sine is how we often think of it when we're finding the exact value of a trig function. Okay? These have to all be memorized. All right. We also went over the unit circle. So are you ready? With your partner right now, draw a circle. Now, whether you understand at this point how do we create the ordered pairs or the coordinates on the outside of the unit circle based on the 30, 60, 90 triangle and the 45, 45 triangle, or you've just memorized, I want you to put the 3 dots in each one of these places. And as I walk around the next 2 minutes, I want to know, how do you get the answers to each one of these dots? And I'll tell you for myself, if I'm going to do it the quick way, I start with these 3 and I build off of these 3. So with your partner, you have 2 minutes right now. Ready, get set, begin. Okay, you guys are being a little bit too loud when you're talking to your partner. If you can just quiet it down. Is anybody a little bit lost right now? Quick hand raise and I'll start explaining. Anybody? Okay, so I'm going to start. I have 1, 2, 3, 1, 2, 3. 2's on the bottom of everything. And anything with the 2 or 3 on top gets a radical. Adriana R., can you tell me how I can use this information and apply it to these 9 other points along the unit circle? Okay, so I'm going to take these and I'm going to write them over here. Let me do that first. So radical 3 over 2 and 1/2, radical 2 over 2, radical 2 over 2, 1/2, and radical 3 over 2, except for the x value or the cosine value is negative. Right, Adriana? Is that correct? Okay, thank you. Erica, can you tell me what else to do? Okay, that's a great way of thinking. Switch pattern. I see a lot of students getting these wrong. So can you tell me what the pattern looks like? I'll point to one of these ordered pair, these locations, and you tell me what to write there. Okay, in this position. Okay, so you want me to go 3, 2, 1. And then what do I do here? So far you're right. You're right so far. Now how do I get the y value or the sine value? Count backwards again. Okay, so 3, 2, 1. Thank you, Erica. And what can you tell me about the signs on these? The right ones are negative. And over here, we take this exact same thing and place it here. So this goes here, and this goes here, and here. And both the x and the y would be negative. Now, as a reminder, how do I get these points? From the origin, you go 1 to the right, and you don't move up or down. 1 to the left, you don't move up or down. You don't move left or right, and you go up 1. And you don't move left or right, and you go down 1. So 0, negative 1. Okay, now draw another circle, please. What is the quickest way to come up with, you're only going to verbalize this. What is the quickest way to come up with the degrees here? So talking to your partner, this time I need to hear talking. 30 seconds, how do I come up with these? Ready, get set, and go. $20 seconds left. Okay, so this is a 3, 6, 9, 12, 15, 18, 21, 24, 27, 30, 33, and 36. What goes in the back of everything? A 0 and a degree symbol, okay? Remember that I am skipping the 45s. That's the key. I am skipping the 45s. Now for 45s, I start on 4. I add 9 to end up with 13. Add 9 to get 22. Add 9 to get 31. And now I attach a 5 on the back with the degree symbol. Now on Friday, we learned how do you come up with the radian measurements for each one of those. So with your partner, you're going to grab the calculator. Remember, it's based on a pattern. Grab your calculator. Don't look at your answers. We know this first one is 1 pi over 6. With your partner, I want you to use the calculators and go, how do I come up with these other 30s? Go ahead. You have 1 minute. Go. Teach your partner if they weren't here. Okay, going to come back up here and do it with you. So at this time, forget about the pi symbol. I'm going to take 1 divided by 6 plus 1 divided by 6. Hit math fraction, enter, enter, and that tells me that this is going to be 1 pi over 3. I'll go up to the next 30. So to this, I'm going to add another additional 1/6. math fraction, enter, enter, and I get 1 pi over 2. Now the rest is easy because I get to just keep hitting the enter key. Enter 2 pi over 3. Enter 5 pi over 6. Enter 1 pi. 7 pi over 6. 4 pi over 3. 3 pi over 2. 5 pi over 3. 11 pi over 6. And 2 pi. Go back to your partner. How do I do, which I'll highlight since this is fairly messy, how do I come up with these 4? And they're the 45s. You ready? 45 seconds, go. Okay, so we're going to start here with 1 pi over 4. So I start with 1 pi over 4. I do the same thing. I'm going to exclude the pi symbol. Now I'm going to add to that 1 over 4, and I'm going to reduce it. So it goes, this is 1 pi over 4, then this is 1/2 pi. We already have that. I'm going to add an additional 1/4 and reduce it. This is going to be 3 pi over 4. Now I can just start hitting enter because I've done the pattern twice. Enter, 1 pi, enter, 5 pi over 4, enter, 3 pi over 2, enter, 7 pi over 4, enter, 2 pi. 1 pi over 4, okay, now go up to the next odd, 3 pi over 4, odd, 5 pi over 4, next odd, 7 pi over 4. Okay, so you need to have that all memorized. At this time, take out a unit circle that is already done, and it's neat for you to see. We're going to do a quick refresher from Friday on something simple. As a reminder, everything is posted there in the video from Friday, so if you need to go back and watch it, please do so. Your quiz will be over this. Identify the exact value of each trigonometric function. So we're going to start with the secant of negative pi over 6. Secant of negative pi over 6. So first, pi over 6 is right here in this location. So from your starting line, you're going to go up 30 degrees or up pi over 6, but it says a negative pi over 6, which means instead of going counterclockwise, I go clockwise for that length. So this is the location that I'm currently at. This is negative pi over 6. It asks for the secant. The secant is the reciprocal of cosine. That means I find the cosine, and remember it's C before S, cosine before sine. I find the cosine and I write it down. Okay, this is the cosine. To the reciprocal of it is 2 over radical 3. And although that's not incorrect, it's not proper. You can't leave your final answer with a radical on the bottom. So I multiply the bottom and the top by radical 3 to get 2 radical 3 over radical 9. And you can reduce radical 9 to 3. Done. Okay, your next one. Tangent of negative 2 pi over 3. So first let's locate positive 2 pi over 3. Positive 2 pi over 3 is 120 degrees from the starting line and going upwards. So counterclockwise 120. So I'm going to go backwards 120. Going backwards 120 has me stopping at this location. Now tangent is sine divided by cosine. So I'm going to identify the sine and I'm going to identify the cosine and divide them in that order. The sine is a negative radical 3 over 2 divided by the cosine of a negative 1/2. Sine divided by cosine. When you divide them, division turns into multiplication and the second fraction flips. What happens to the 2 on bottom and the 2 on top? And what happens to the negative and a times a negative? They cancel because a negative times a negative is a positive. So I have positive radical 3 over 1, and if you leave it like this, that's okay. Or know that anything over 1 is just itself. Okay, your next one. The cosine of negative 90 degrees. So 90 degrees from your starting point goes up and it's at the very top. So I want to go in the opposite direction because it's not negative. So I go down and I stop. What is the cosine? C before S. So the cosine is 0. Okay, your next one. We're going to go with the cosecant of 3 pi over 4. Cosecant of 3 pi over 4. So 3 pi over 4. 3 pi over 4, it doesn't have a negative, so I get to go counterclockwise and remain there. And then I have to recognize, okay, cosecant, what does that mean? That is the reciprocal of sine. So let's first identify the sine. The sine at this location is positive radical 2 over 2. But I need to flip it because it's reciprocal. So instead of positive radical 2 over 2, it's 2 over radical 2. That's not mathematically wrong, but it's not proper. I need to multiply the bottom and the top by radical 2. 2 radical 2 over 2, and done. Okay, going to have you try 2 with your partner before we go on to some new things. You take your quiz a little later. Here's the first one. We'll actually have you try 3. Okay, with your partner, there's 3. I'm going to give you 3 minutes. I'll walk around. Please make sure you're talking. Martine, how are you feeling? You okay with this? I'm going to start at number 1. As soon as you get done, look up here, then keep going on to number 2 if you have it correct. So, cotangent of pi over 3. Cotangent, if you look back on your paper, is cosine divided by sine. Cosine divided by sine. Okay, so I'm going to change division into multiplication. I'm going to flip the second fraction. Your 2's cancel out, and although this is not incorrect, it's not proper. Multiply the top and bottom by radical 3. Final answer. Can you raise your hands if you have the first one correct? Hands up high. 1, 2, 3. What'd you say? So you could put a 1 in front, absolutely. Yep. Okay, tangent of pi over 2. So pi over 2 is at this location. Tangent is sine divided by cosine. So 1 divided by 0 and 1 divided by 0. You can never have 0 on the bottom. Final answer is undefined. Not 0, not 1, undefined. Secant of negative 5 pi divided by 6. 5 pi divided by 6 is a 150 degrees from your starting point. So I'm going to go backwards 150 to this location. Now secant is the reciprocal of cosine. Secant is the reciprocal of cosine. So let's identify the cosine at this location. Here's negative 5 pi over 6. The cosine is negative radical 3 over 2. So negative radical 3 over 2, and I'm going to write it as the reciprocal. And although this is not wrong, it's not my final answer because I have a radical on the bottom. Times radical 3 times radical 3. 2 radical 3 over radical 9. You have one negative in there. And we can reduce the radical 9 to 3.
So in the formula it says 1 over the secant. So where did you go? Why did you
Which formula?
for the secant?
Okay, so secant is 1 over the cosine, which just means the reciprocal of the cosine. So identify the cosine and flip it.
Oh.
Good question. Does anybody have any other questions for me on 1, 2, or 3? Yes? Okay, so I'm going to go I'm identifying negative 5 pi over 6 on the unit circle. So positive 5 pi over 6 is 150 degrees counterclockwise. So I'm going to go opposite clockwise 150, and I end up right here. Do you recognize that? Yeah. And then secant is the reciprocal of cosine. So I'm going to find the cosine, and then I'm going to flip it. The cosine here is negative radical 3 over 2, so it's going to be negative 2 over radical 3. And then I just work through it to make sure there's no radicals in the bottom. Okay with that? Okay. Great questions. Here we go. We're going to move on now. Here's your next part, the new learning. You'll go back and have a quiz on that in just a little bit. Please write down for me. Please listen. Find the value of the 5 trig functions. Find the value of the 5 trig functions. You're writing this down on your paper. Okay, here we go. The sine is equal to negative 2 over 9. The sine is equal to negative 2 over 9. And you're told that this angle is between 3 pi over 2 and 2 pi. So the first thing we need to do is we need to draw a circle. It does not need to be large, maybe like the size of a quarter, a little bit larger than that, $50. And I want you to make your 4 quadrants. As a reminder, this is quadrant 1, 2, 3, and 4. This says that it is between 3 pi over 2 and 2 pi. So it's between those 2 points, which would make it quadrant. That's why in quadrant 4, what are the sine values or the y values down here? That's why this is negative. Okay, does everybody see that? Now we need to come up with the 5 remaining trig functions. So let's write this down. Sine equals negative 2/9, cosine, tangent, cosecant, secant, and cotangent. So I need these 5 remaining items. Each time I get it, I'm going to circle it so I know it's done. So I'm given this one. I already have it. By the way, this is the easiest one to find. And the reason is, what are these two? They're just reciprocals. What is the reciprocal of negative 2/9? Negative 9 over 2. Done. So I know it's in this location. By the way, let's talk about this really quick. What is the y value down here? Negative. That's why both of these are negative. What is the x value here? Tangent and cotangent. Both mean take the sine divided by the cosine or the cosine divided by the sine. So if you take a negative divided by a positive, you're going to end up with a, and again, if you take a positive divided by a negative, you're going to end up with a negative. Now we need to come up with those numbers. So you're going to start from the origin, and I want you to, it doesn't really matter what this angle is, but I want you to go from the origin straight out until you hit this curve. Now, how did I define this curve? Because this curve is between 3 pi over 2 and 2 pi. It's what's given to us. So go straight out and hit it. Once you touch it, you're going to go straight up to the x-axis. We always go back to the x-axis. And I want you to create that triangle. Now, I personally think it's easier to work with larger triangles, so I'm going to replicate this triangle off to the side. And the central angle is what's formed between the x-axis and the new line you've created. If we are told that the sine, now at this point, by the way, we don't even worry about these positives and negatives anymore. Those are only determined by which quadrant it's in, and we think about it in terms of like x's or y's, which converts to cosine and sine. So if we're told the sine is 2 over 9, forget about it being negative, 2 over 9. Which side would have a 2 and which side would have a 9? Well, sine means opposite over hypotenuse. Opposite of this angle is 2. Hypotenuse is 9. There still has to be some students that are saying, but it's negative, miss. Remember, this negative only represents that it's in quadrant 4. So forget about the negatives. We need to find this missing piece. With your partner, please do the quadratic formula to get this, and you have 30 seconds. Ready, get set, go. So we have 2 squared, the two legs are 2 and x. 2 squared plus x squared equals 9 squared. Then I'm going to subtract the 4 to the opposite side to start isolating the x. I'm going to take the square root of both to have x be by itself. And now the last thing we have to ask ourselves is, are there any perfect squares that divide into 77 so that I could reduce this? So let's just try. I know the answer, but let's try. Let's take 77 divided by 4. Nope. 77 divided by 9. For those that may be confused, I'm going to take 77 divided by, what's the next one? 4, 9. 16. Nope. 77 divided by, what's the next one? 25. Doesn't work. 77 divided by next one. Doesn't work. 77 divided by 49. Nope. And 77, whoops, divided by 64. Okay, so it cannot be reduced using perfect squares. That's an 8th grade concept. So up here I'm going to write radical 77. Now how is that going to help me answer these? Because on this piece of paper we said the cosine is adjacent over hypotenuse. So from this angle, adjacent, remember it helps create the angle and it can't be the hypotenuse. So adjacent is radical 77 over hypotenuse 9. Now, when you take the reciprocal, you get 9 over radical 77. Is that incorrect, yes or no? Well, it's not incorrect, but is it proper? So I'm going to go times radical 77 times radical 77. 9 times radical 77 over 77. Okay, tangent. Tangent is going to be opposite over adjacent. Opposite over adjacent. So opposite is 2, adjacent is 77. Opposite 2, adjacent 77. Again, this is not mathematically wrong, but it's not proper. So I'm going to take it times radical 77, and I'll get negative 2 radical 77 over 77. For cotangent, let's look at the original. Cotangent says cosine over sine. Your cosine over sine, or adjacent over hypotenuse. Your adjacent is radical 77, and your opposite is 2. Problem done. Please make sure you have all the notes so you understand how to do that for your quiz. Yes, Rodrigo?
How did you determine that the bottom ones are negative versus?
How do I determine these are negative? Great question. Okay, please make sure you're quiet so I can explain to Rodrigo. Tangent is going to be sine divided by cosine, right? So what is the sign, positive or negative?
It's negative.
And this is?
Um,
So a negative divided by a positive is a?
um,
Does that make sense to you?
yeah.
And cotangent is cosine divided by sine, so positive divided by negative is a negative. Okay, flip. What'd you say? In this quadrant, in quadrant 4, your x's are positive, your y's are negative. Make sense? Okay, flip to the back side, please. Here's your next one. You're going to be given, so please write down your sine, cosine, tangent, cosecant, secant, and cotangent. Okay, and draw a circle off to the side. This time, you're told that your cosine is negative 3/5. Negative 3/5. So the secant, by the way, is really easy. What is the secant? Negative 5/3. Okay, and you're told that this angle that we're working with, this angle occurs, between pi over 2 and pi. So locate where is pi over 2 and where is pi, and what is the arc that connects them? What quadrant are you in? Okay, so in quadrant 2, what are the sine values? You tell me, what are the sine values? Like they're like y's or sines. Positive or negative here? Positive, positive. What are the cosines? Both negative. So ready? Let's talk about tangent. Tangent is sine divided by cosine. What's a positive divided by negative? And cotangent is cosine divided by sine. What's a negative divided by positive? A negative. All right, you ready? So let's start from the origin. Go straight out until you hit some point on the curve. Doesn't really matter where you hit. Then always go back to the x-axis to create that 90-degree angle. And I'm going to replicate that triangle down here a little bit larger. And the angle created with the x-axis is going to contain your central angle. So at this point, we don't care about positives or negatives. We've already determined what they're going to be. Cosine is 3/5. So cosine represents the adjacent over the hypotenuse. Adjacent would be this side. Hypotenuse is this side. We need to figure out this. You have 20 seconds. You can use your partner for help if you need to. Quadratic formula. I'm sorry, not quadratic formula. The Pythagorean theorem to find out x. Go ahead. Okay, Fabio, what did you get? 4. Good. So we have 3 squared plus x squared equals 5 squared. I subtract 9 to get 16. Take the square root of it to get 4. Nice job. Put a 4 here. So let's go up to sine. Sine means opposite over hypotenuse. 4/5. Reciprocal, 5/4. Done, 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 and done. Tangent means opposite over adjacent. Opposite over adjacent is 4/3. Done. Now the reciprocal is 3/4. Done. Okay, talk to your partner about the last 2 problems before we go on to one more type. Go ahead. you. Okay, this is your next problem, your last type. It's the same concept, it's just a little bit different. It's written a little bit differently. Write it down before I start. I'll give you a chance to put it down on paper. This is 11 over 12. 11 over 12. So make yourself a circle. And they don't say it's between this point and this point on the circle. They just straight up tell you what quadrant it's in. So what quadrant is it in? Quadrant 4. So go to quadrant 4 and darken this in. And for the last few problems, we've had to find 5 different trig functions. They only want us to find one additional one this time. Which one do they want you to find? So we're told, let's start here, go straight out till you hit that curve, then always back to the x-axis to create the 90-degree angle. And the angle created, the central angle created with the x-axis is going to have the theta symbol, and I like to replicate it off to the side to make it a little bit neater. So let's talk about this first of all. We know the cosine is over here, right? What do you know about the sine value here? It's negative. How do you know it's negative? Because sines are like y values, and in this quadrant, the y's are. So I know my final answer is going to be negative. I know that right off the bat. Okay, so we're told the cosine is 11 over 12. So here's my angle. Cosine is adjacent over hypotenuse. Adjacent over hypotenuse. With your partner, please find the missing side.
How can you determine if it's already going to be negative?
Sure. In this quadrant, tell me what the x's are.
Positive,
And what are the y's?
negative, or positive,
And here, x is,
negative,
y's are.
positive,
Here,
negative, negative,
and here.
positive, and negative.
And your x's are always like your cosines, and your y's are always like your sines. Okay? So, anybody want to tell me what the missing number is? Did you get 5? Did you get square root of 25? Yes or no? No? Let me try. So, do you have 144 equals 121 plus x squared? Okay, subtract 121. What is 144 subtract 121?
23.
Oh, so 23 equals x squared. So how about square root of 23? Better? Okay, so then we're going to do the sine, which is opposite over hypotenuse. Opposite over hypotenuse. Now there has to be some students that say like, Miss, how do I know when I need to multiply both the top and bottom by 23? Or when I can say this is my final answer? Does anybody know?
When the radical is on the bottom.
Right. When the radical's on the bottom, then you have to multiply by both. So for instance, if your answer would have looked like this, 12 over radical 23, that's when you have to multiply both, okay? You have to rationalize the denominator. But here, the radical's on top. We're not breaking any math rules, and we're done.